Welcome back to educator.com. For the next lesson, we're going to go over how to find probability of an event not occurring. So we've gone over the probability, how to find the probability of an event occurring. And that would be the desired outcome over the total possible outcomes. So it's a ratio, right? We're comparing what we're looking for, the desired outcome, over how many total possible outcomes there are. What's the total number? Now, this ratio is in the form of a fraction, right? Top number over bottom number. Probability can also be in the form of a decimal and a percent. So if I have probability of an event occurring, let's say it's 1 over 4. If that's the probability, well, I can change this into a decimal and into a percent, right? So let's just review over that. To change this fraction to a decimal, I'm going to take the top number and divide it to the bottom number. So this top number is going to go inside, the 4 on the outside. Now here, I'm going to add a decimal point. I can always add a decimal point at the end of a number, right? And then I can add zeros. I can add zeros as long as it's behind the decimal point and at the end of the number. Bring this decimal point up. Now 4 does not go into 1, so I'm going to use 1 0 to make 10. So 4 goes into 10 twice, and that's going to give me 8. I'm going to subtract the 10 with the 8. I get 2. I can add another 0, bring that 0 down. 4 goes into 20 5 times. That's going to give you 20. Subtract it, I get 0. Okay, so then 1 over 4 is the same as 0.25. You can also think of it as 1 out of 4. Let's say I have 4 quarters. 1 out of the 4 quarters gives me 25 cents, right? And then to change this to a percent, I take the decimal point and I always move it to the right 2 spaces. Think of a decimal as being small and a percent as getting larger. Percents are bigger than decimals, so we have to move it to the right to make the number bigger. So I'm going to move it to the right 2 spaces. Okay, so the decimal point is now going to be behind the 5 at the percent sign, and that's how you change it from decimal to percent. So 3 ways we can write probability. Now, that's the probability of an event occurring, right? So to find the probability of an event not occurring is actually going to be 1 minus that number. Now, 1, why 1? 1 is actually the biggest number we can get for probability. It's like saying the whole thing. Say I have a bag of marbles. And in this bag of marbles, I have, let's say, 4 red marbles. Well, if I want to find the probability of picking a red marble, okay, probability of my event will be picking a red, right? So how many red marbles do I have? I have 4. So my desired outcome is 4 out of, how many total marbles do I have? 4. Well, 4 over 4 simplifies to get 1. So 1 represents the whole thing. It represents all of it. Okay, so the probability of something happening is 1. That means it's a 100% chance that it's going to happen. So that is why when you look for the probability of an event not occurring, it's as if you're going to take that 1, the whole thing, and you're going to find the leftovers. So, back to the bag of marbles. Let's say I add 2 blues. Okay, now I want to find the probability of picking a red. So, now I have, well, I still have 4 red. out of the total number of marbles change, right? I now have 6 marbles. So here, my probability is, I could simplify this, divide each of these by 2. I get 2 over 3. That's the probability of the red. Now I want to find the probability of it not being red. Okay, so then the event not occurring. So the probability of not red, okay, I'm going to take the whole thing, which is 1, right? Subtract it from the event occurring, 2 over 3. So it's like finding the leftovers. From the whole thing, if I take away this much, which is the actual probability of the event occurring, then it's like I'm finding what's left over. So here, in order to subtract this, I need to make this the same denominator with this. I can turn one whole into, as long as my top number and my bottom number are the same, it's still 1. 3 over 3 minus 2 over 3. I made it 3 over 3 because I want this denominator to be 3, the same, for me to be able to subtract these fractions. This becomes 1/3. So, another way to explain this, the probability of picking a red is 2/3, right? The probability of not picking a red is all the rest of it, which is 1/3. Together, the probability, it's either red or not red, right? It's either going to be red or it's not red. It's one of those two. So, this is the probability of picking a red. This is the probability of picking one that's not red. Together, they make up the whole thing because it's going to be one or the other. And the whole thing is just 1. So the probability of this not occurring is 1/3. So the first example, we're going to use a spinner. We want to find the probability of spinning or landing on a color that's not green. Now, we can do this 2 ways. When we have something like the spinner, or maybe a bag of marbles, it's a little bit easier. We can make all the colors that are not green our desired outcome. So, I can look for all of the colors that are not green. I have 1, 2, 3, 4 that are not green. So my desired outcome, again, is not green. There's 4 of them. Over, total of 5. So the probability of not green will be 4 over 5. Now, the way we did it before, previous slide, it's like finding the probability of actually having green and subtracting that from 1. So we can find the probability of green, subtract it from 1, and we're still going to get the same answer. So here, probability of picking a green, that's 1 green out of 5, right? So this will be 1 minus 1 over 5. I can change this whole number into 5 over 5 to make the denominators the same. 5 over 5 minus 1 over 5. 5 minus 1 is 4 over, keep the denominator the same, and I'm going to get the same answer. Now, this is obviously the easier way to do it. So if you can do it this way, then that's fine. But you still have to understand that 1 whole would be the whole thing, right? There's 1, 2, 3, 4, 5 out of 5, and that would be 1 whole. So, to find the probability of something not occurring would be taking the whole thing and subtracting it by the actual probability of the event occurring. Okay? Now, this next one here, the probability of not red or orange. So again, we can just make this, all the colors that are not red or orange, be the desired outcome. How many are not red or orange? Here's red, here's orange. How many are not either of these? I have 3. So my desired outcome would be all the colors that are not red or orange. That's going to be my top number. That's 3 over total of 5. Okay, so that would be my answer. But again, we still have to understand that I can find the probability of the red or orange, and then take the whole thing, subtract it, right? So how many are red or orange? I have 1, 2, 2 out of 5. 1 minus 2 over 5. Again, change this to 5 over 5 minus 2 over 5. And that's going to give me 3 over 5. Given the probability of an event occurring, find the probability that the event will not occur. Okay? So here, probability of event A occurring is 1/4, 1 over 4. The probability of the event not occurring is 1 minus this number, right? So it's going to be 1 minus 1 over 4. So again, change this number, whole number, it's 1, so then the top number and the bottom number has to be the same. So I want to change this to a fraction, and the denominator has to be a 4. So it'll be 4 over 4 minus 1 over 4. Again, I made it 4 over 4 because it has to stay a 1, and the denominator has to be the same. So this is 4 minus 1 is 3 over 4. So if the probability of an event occurring is 1/4, then the probability of the event not occurring is 3/4. So, and it's like if 1 is the whole thing, right? 1 over 4, let's talk money. 1 over 4, 1/4 out of 4 quarters. If you use 1/4, how many quarters do you have left? The remaining of it is 3/4, right? So you have 3 left. So 1/4 left over is 3/4. So the rest of it is 3/4. That's the probability of it not occurring. Okay, here, so decimal 0.67. Again, so 1 minus the probability of the occurring would be 1 minus 0.67. So again, if this is $1 minus 67 cents, what do you have left? So to subtract decimals, we do 1.00, and I'm just turning this 1 into 1.00, because when you subtract decimals, you have to line up the decimal points. So it's going to be 1.00, and again I added zeros because it's at the end of a number behind the decimal point, minus 0.67. This 0 I'm going to change to a 10. I borrowed it from this, right? That became a 9. And then this becomes 0. So 10 minus 7 is 3. 9 minus 6 is 3. And then nothing there. Bring down the decimal point. So the probability of this not occurring is 0.33. And for this one, the probability of event C happening is 42%. The chance of this occurring is 42%. So what's the chance of it not occurring? Well, this is a little bit different because it's a percent. Now the whole thing in a percent would be 100%, right? So if you have a percent, then you'd have to do 100% minus the 42%. Or you can think of it as still 1 minus probability of C occurring. And then, since it's percent, now we can change it here. 100%. Okay, we're changing this one whole into a percent. So again, decimal point at the end. Move it 2 spaces over. That's 100% minus 42%. And then 100 minus 42 is 58%. Okay, the third example here, the probability of Susie passing the math test is 85%. Find the probability of her failing the test. Okay, so her passing, the probability of an event occurring, which is her passing the math test, is 85%. We have to find the probability of her failing the test. So it's out of a possible 100%, right? So we know that from 100%, we have to subtract the percent of the probability that she's going to pass the test to see what the probability of her failing the test is going to be. So from here, this is 15%. So this and this together have to make up the 100%, because that's the whole thing. She's either going to pass it or she's going to fail it, right? So this is the pass, and this is the fail. Together, they have to make up the 100%, the whole thing. So probability of her failing the test is going to be at 15%. The second one, the probability of Sam not picking the correct color marble from a bag is 5/8. Find the probability of him picking the correct marble. Okay, so the probability of Sam picking the marble, let's just say marble, the correct marble. Now, this is what they're asking for, right? They want to know what the probability of him picking the correct marble is going to be. Well, he's either going to pick the correct marble or he's going to pick the incorrect marble, right? So here, to find, now we know, okay, so then the probability, what's given to us, of not picking the correct